Well, greetings everybody. Sorry I'm gone today. I hate to be gone today mainly because this is a very tough day today. Not trying to scare you anything, but this is a pretty tough day today. Here's our plans for the day. If I were there, I'd answer any questions over that material, but since I'm not, we'll have to hang on to those. We will quiz you here in just a couple of minutes on how to find the inverses. I will review a couple of those with you on this video, and then my sub can hit pause during the quiz, and then once we hit play again, the video will just pick back up. But what I got to do today is I got to build on what we started last time, reducing the radicals. Last time they were all perfect squares, perfect cubes, perfect fourth roots. Today we're going to mix them up a little bit. So I will have to show you that as we go. So hang with me. It is a non-calculator day. You can use your calculator on finding the inverses. You shouldn't need to, but it's green light there. But on the class examples and on the assignment, it's not. So let me get you ready for your quiz real fast. You should have that little third sheet or quarter sheet of paper that had the steps on how to find an inverse. That is fair game on the quiz. If you don't have one, my sub will be able to give you some because I left some there. But let me just review with you real fast. Let me give you a simple one. Let's go f of x equal 5x minus 4. And let's find the inverse of that. Well, your first job is to sketch a rough graph of it just to make sure it passes the horizontal line test. Because if it doesn't pass the horizontal line test, we just write it, tell it that it's not going to be a function, and we're done. I know this thing would start down here at -4 because it's a line, up 5 and over 1. So I know a real rough graph is going to look like that. It definitely passes the horizontal line test. So now let me move on. If you look at the steps on your sheet, the first step says graph it. The next step says rewrite f of x as y. So one step is I've got y equal 5x minus 4. The next step says switch the x and the y. So x equal 5y minus 4. And then the next step says solve this thing for y. So do whatever it takes to solve for y. In this case, I need to add 4. So I got x plus 4 equal 5y. Now I need to divide both sides by 5. So I've got x plus 4 all over 5 equal y. The last step says write it with correct notation. So here's my answer. f negative 1 of x is x plus 4 all over 5. That's all there is to it. Let me review another one with you. Let me review one with the radical in there. Let's look at f of x equal the square root of x minus 7 plus 2. Kind of a harder one then. Hey, a rough graph of this. I know this thing's going to go 7 units to the right and up 2 and look like that. Okay? Notice that I don't care how accurate the graph is. All I care about is it will pass the horizontal line test. Now I'm just going to follow those steps again. Rewrite f of x as y equal the square root of x minus 7. When a radical is involved, you got to get that radical by itself. So first, let me switch the x and the y. Now let me get that radical by itself. So I need to subtract 2 from both sides. So I've got x minus 2 equal the square root of y minus 7. Now do whatever it takes to solve for y. In this case, to get rid of this square root, I'm going to square. So I'm going to square this side, which on this side just gets rid of that square root. Now to get y by itself, I'm going to add 7 to both sides. We could FOIL this out, but we're not going to. It's not wrong if you do, it's just extra work. Let me write it with correct notation. Go away. Let me write it with correct notation. f negative 1 of x is x minus 2 squared plus 7. So there's my answer. But do a good job of following all of these steps as you go. Okay. The quiz shouldn't take you more than 10 minutes or so. So I will scroll this on. I'll ask my sub to hit pause on the video. After we get everybody's quizzes, we'll continue on with the class notes and the video. Good luck. And welcome back. Hopefully you did extremely well on the quiz. Let me show you what we got going on now. I got to remind you how to reduce radicals. The hard part of this is it's non-calculator again. So this is one of those, do you remember? And the answer should be yes, by the way. Do you remember how we simplified the square root of 50? What did we have to do? We had to write this as something that I know the square root of times something that I don't know the square root of. Something you know the square root of? 25. Something you don't know the square root of? 2. My ending answer then is going to be 5 square root of 2. So we had done those earlier. We did them with the quadratic formula. We did it when we completed the square. We did it in the section where we reduced our radicals. What's going to make it tougher today? I'm going to add different variables with it, just like I did last time. Remember last time, guys, if I had the cube root of a to the 6th, b to the 9th, all we did was went a to the 6 divided by 3 and b to the 9 divided by 3, so we got a squared b cubed. What I got to do today with you is you may see something that looks like the cube root of x to the 7th. Hey, the bad thing here, 7 divided by 3 is not a pretty number. So here's what we have to do when we see something like that. I need to write it as the cube root of x to the something. Here's what I need. I need the biggest number that 3 goes into that's less than or equal to 7. So 3's got to divide into it. So I'm going to use a 6, because 6 divided by 3 is a good number. What's that leave me left over? The cube root of x to the 1st. Why can I do that? 6 plus 1 is 7. Here's what this weird looking answer would look like. This is going to become x squared, because 6 divided by 3 is 2. And this part stays as the cube root of x. So you're going to see some of that today. Let me show you another one really, really fast. And then I'm going to jump onto your class examples. So let's look at the 4th root of a to the 22nd. 5 does not go into 22 nicely. So I have to write it as the 5th root of something times the 5th root of a to the something. The number that you put right here, 5 has to divide into it. So count by 5s. 5, 10, 15, 20, 25. The biggest number that I said before I passed 22 was a 20. So I need a 20 there and a 2 there. 20 plus 2 is 22. Then here's what this answer now looks like. A to the 20 divided by 5 is 4. This part, you don't bother. So it stays as the 5th root of a squared. So it looks weird. What's going to be tougher is there's, of course, no calculator involved today. So if you will, jump over to your class examples. I tried to start kind of easy, and what's tough on a day when I'm making a video is I like the pause time to give you time to answer. I'll try to utilize a little bit of that there in the video, but it gets tough. So follow along with me. Try to think ahead of me if you can. So look at your number 1. I got 5 times the square root of 54. I'm going to think of this as 5 times. I need some number that we know the square root of, and you don't get your calculator, times some number that we don't know the square root of. So I need something I know the square root of and something I don't. I'm going to think of 54 as 9 times 6. The reason being, the square root of 9 is 3. So here goes my answer. This now becomes 5 times 3 times the square root of 6. 5 times 3 is 15, so here's this answer. 15 square root of 6. So you got to write it as something that you know, something that you don't know. Here's my number 2. Something that I know the square root of times something that I don't know the square root of. So do it piece by piece. I need a number that you know the square root of that goes into 75. Hey, and any time you see something like 25, 50, 75, 125, 150, 175, 25 is an automatic number. So I've got a 25 and a 3. Now remember, there's an invisible 2 right there, hence the word square root. So I need an x to the something. Whatever number you pick, 2 has to go into it. But I want it to be as big as you can. So 2 goes into 4, so I want to use that 4. So that means I don't have any x's over here. I'm going to have a y to the, find me the biggest number that 2 can go into that's less than 7. If you have to, start counting by 2's. 2, 4, 6, 8. Oops, 8 is more than 7, so I need a 6. So I'm going to think of this as y to the 6th times a y to the 1st, because 1 and 6 make 7. Now that you've done this step, now I can simplify. The square root of 25 is 5. X to the 4 divided by 2 is 2. Y to the 6 divided by 2 is 3. And this part does not reduce. So there's your answer. So I know it's kind of tough, but the more you do, the better it gets. Here goes your number 3. I need something that I know the square root of times something that I don't. So think for just a second, a number that you know the square root of that would divide into 32. I'm hoping that you're seeing a 16. So over here must be a 2. Now I need an x to some power. It's got to be less than 9, but 2 has got to go into it. So that's going to be a 8, which leaves an x. Ending answer now, the square root of 16 is 4. X to the 8 divided by 2 is 4. That's the first piece of it. This piece just stays the same because it will not reduce. So that's what we got going. And guys, it's really one of those things, the more you do, the better you get at it. Practice makes perfect in this case. Look at your number 4. I need something I know the square root of times something that I don't know the square root of. So find me a number that you know the square root of that goes into 12. I'm hoping that you would say 4 times 3. I need a c to the, there's a 2 hiding right there. 2 goes into 6 already, so good deal. That's a 6. That means I don't have any c's over here. D to the, I'm hoping you thought second, and a d. Now when I reduce this, the square root of 4 is 2. C to the 3rd, d to the 1st, times the square root of 3d. And then we're done. But here goes my number 5. Notice that I'm going to pick on some cube roots for a little bit. So it's going to be something that I know the cube root of times something that I don't know the cube root of. Do you know the cube root of 27? And the answer is yes. So I'm going to use a 27. Nothing over here yet. I need a y to the, since 3 goes into 12, I'm using it. 12. Nothing over here. Z to the, 3 doesn't go into 7 nicely, so I need a 6, and I need a z over here. Now let me go get the answer. The cube root of 27 is 3. Y to the 12 divided by 3 is 4. Z to the 6 divided by 3 is 2. Times the cube root of z. As weird as it looks, guys, that's my answer. I'm going to just keep clicking these off. Here goes your number 6. I need the cube root of something that I know times the cube root of something that I don't know. A number that you know the cube root of that goes into 16, I know the cube root of 8, which leaves me a 2. Hey, notice I haven't used that negative yet. What we traditionally do is put it with the main number. So I know the cube root of 8 is 2, so the cube root of negative 8 must be negative 2. So we'll use that in a second. I need an a to the 5 doesn't go in, 3 doesn't go into 5, so I need a 3, which leaves me 2 a's left over. B to the 6th leaves me a b left over. Now let me simplify this piece. The cube root of negative 8 says what times what times what is negative 8? Well, that's going to be negative 2. A to the 1st, b to the 2nd, and then the other part we just write down. So there's that answer. Moving on. They do get a little easier here in a second when we just FOIL them out. Number 7. Oh boy. I need the 4th root of something times the 4th root of something. So we got to find a number that you know the 4th root of. So we know the 4th root of 1 is 1. Let's pick on 2 for a second. What is 2 times 2 times 2 times 2? That is 16. So I'm going to use a 16 and a 2. Reason being, I know the 4th root of 16 is 2. I need to go a to the 8th, which leaves me an a there. And since 4 goes into 20, I need a b to the 20 there. So final answer, the 4th root of 16 is 2. A squared, 8 divided by 4 is 2, b to the 5th, times the 4th root of 2a. So keep hanging with me. I know these are tough. Here goes my number 8. I need the 4th root of something again, times the 4th root of something. Well, we know the 4th root is 16 because we just used that. So I'm going to use all of the 16. 4 goes into 24, so I'm going to use all 24 of the a's. So I have nothing over here yet, but I need a b to the 12th, which leaves me a b. I needed the highest multiple of 4 that goes into 13. So if I started counting, 4, 8, 12, 16, that's over 13, so there's one I need. The 4th root of 16 is a 2, a to the 6th, b to the 3rd, times the 4th root of b. Hey, if there's a fraction, big deal. We're just going to do that like we did last time. I'm going to think of this as the square root of 36a to the 8th over the square root of 49b to the 6th. This is a nice one, guys, because check this out. I know the square root of 36 is 6. 8 divided by 2 is 4, so the top simplifies to be that. The bottom, square root of 49 is 7. 6 divided by 2 is 3. Bam, got that one done. So every now and then they'll reduce nicely. Number 10 doesn't reduce nicely. Number 11 does. So I'm going to think of this as a to the 6th, b cubed, over the square root of 49. So I need something I know the square root of times something I don't know the square root of over, I know the square root of 49 though is 7. So I'm going to use a to the 6th because 2 goes into 6 nicely. And I'm going to use a b squared, which leaves me a b right there. Ending answer, a to the 3rd b over 7 times the square root of b. Then I'm going to look at number 11, then I'm going to jump over to that back page a little bit. On number 11, guys, you're going to think of this as x to the 6th over the square root of y to the 12th. And we're going to go get each answer. Since 2 goes into 6 nicely, the top is just x to the 3rd. The bottom is y to the 6th. And then we're done. Okay. So keep working on those. Hey, let's bypass number 12 for a little bit because I want to make a little bit of time. Let's come over to your number 13. We've done this before a chapter ago. We've done this before a chapter ago. We reduced all these and combined like terms. So here's what it's going to look like. 3 radical 2 doesn't reduce, so write down your 3 radical 2. And then plus. Here's what you got to ask yourself now. Does the square root of 50 reduce? And it does. Something you know the square root of, 25, times something you don't know the square root of, 2. And I got minus 4. Now look at the square root of 8. Is there a number in there that you know the square root of? Yep. The square root of 4 times the square root of 2. So I wrote them all as radicals. Here's my next step then. 3 radical 2 does not reduce. Plus, to reduce radical 25 times radical 2, square root of 25 is 5 radical 2. Now on this one, the square root of 4 is 2. 4 times 2 is 8 radical 2. Since all of these have a radical 2 in it, they're like terms. Just like if it was 3x plus 5x minus 8x. Same thing. So I'm going to add the 3 and the 5. That makes 8. 8 minus 8 is 0. So I have 0 radical 2. So in this case, after all this work, my answer is 0. My number of Facebook friends. After all that work. So look at your number 14. I got 2 square root of 50 plus 4 square root of 500 minus 6 radical 125. Oh boy. Well, here goes. I got 2. I need something that you know the square root of that goes into 50. Since we just did that over here, I'm going to think of this as 25 and 2 plus. I've got a 4, so just write that down. Something within 500 that you know the square root of. Hey, and anytime something ends in a double zero, it's automatic. 100. Minus 6 times, how about 125? Is there a number within there that you know the square root of? 25 times 5. So now you got to go through and simplify each. So square root of 25 is 5 times 2. So this piece now is 10 radical 2 plus square root of 100 is 10. 4 times 10 is 40 radical 5 minus the square root of 25 is 5. 6 times 5 is 30 radical 5. Now we go through and combine any like terms. This guy's a loner, so we just write them down. But I can combine 40 and negative 30 because they each have a radical 5, which makes them like terms. So 40 minus 30 is positive 10 radical 5. And then stop. That's your answer. So it's just reducing a bunch of radicals. So guys, the sooner you get to know all those numbers, the better off it is. Here's number 15, another easy one. Square root of 20. Something that you know the square root of. I'm hoping that you quickly saw 4 and a 5. 125. Anytime it ends in a 25, there's a 25 and a 5. Minus, how about out of 45? A little shortcut that I use. The digits add up to be 9. I know that 9 goes into it. 9 and 5. So there I've reduced them. Now the square root of 4 is 2, so I've got 2 radical 5, plus the square root of 25 is 5, so I got 5 radical 5, minus square root of 9 is 3, 3 radical 5. Now let's go get our final answer. They all have a radical 5 in it, so that's good news. 2 plus 5 is 7. 7 minus 3 is 4. Radical 5 is my answer. If I was there, I'd have you try number 16, and then we'd kind of pick on some more. So let me hit number 16. I'm then going to bypass number 17. So out of 300, square root of definitely 100 times the square root of 3 minus, how about out of 27? Square root of 9 times the square root of 3 minus, out of 75, square root of 25, square root of 3. Square root of 100 happens to be 10, radical 3, minus, square root of 9 happens to be 3, radical 3. Square root of 25 happens to be 5, radical 3. Once again, radical 3's everywhere. 10 minus 3 is 7. 7 minus 5 is 2. My final answer, 2, radical 3. Okay. Now number 17 is going to be just like it. So I'm not going to worry about that one. But let's look at number 18. And then what I did is I just kind of mixed up some review. So look at number 18. If I was there, I would ask you, guess what we're going to do? And I know that somebody would say, we're going to have to distribute. Because that's what we do every time there's parentheses. So I know I got to do this to this. So to do that, guys, you can multiply the whole parts together and the radical parts together. So this becomes 2 times the square root of 45. 2 times 1 is 2. 3 times 15 is 45. Notice I put the radical parts together, just like we did before. We did a problem very similar to this in that other lesson. Plus, this becomes 2 times the square root of 180. Now we got to break down each radical. So this becomes 2 square root of 9 square root of 5 plus 2. I need something that we know the square root of that goes into 180. So I might guess 16. That would give me a 10, 11. We might have to toy with that just a little bit. So it's kind of a hard one. Let's take something obvious, and I'll show you if you did this. I know that 9 goes into it and leaves me a 20. So let me show you what happens here. This becomes, the square root of 9 is 3. So I got 2 times 3 times the square root of 5. So this piece is 6 radical 5. Plus, this becomes 2 times 3. So I've got 6 square root of 20. But we're not done yet. 20 reduces some more. So I got to leave this piece alone. I need to think of this as a 4 times a 5. Final answer, we'll see. 6 radical 5 plus the square root of 4 is 2 times 6 is 12 radical 5. Ending answer looks like 17 radical 5. It also means this, guys, when we looked at 180 earlier, if I would have thought of that as 12 and something, I could have got that answer a little quicker. Okay. So look over at your number 19 and 20. I'm going to do number 19, 20, then I'm going to show you a foil or two, and then we'll have this thing whipped. Because I noticed my video is getting a little long. I was shooting for about 35 to 40 minutes max. Hey, so on this one, guys, check out what we got to do. 6 times 4 is 24. Times the square root of, put all those together. 8 times 2 is 16. C to the, when we multiply, what do you do to your powers? Hopefully you remember from last chapter that we add them. So I got C to the 4th, D to the 8th. Now let's reduce this. This becomes 24 times the square root of 16 is 4. C to the 4 divided by 2 is 2. D to the 8 divided by 2 is 4. Now we're ready to go get our answer. 24 times 4, 96. C squared D to the 4th. So moral of that story, if we're multiplying, you can put radical parts together and you can put the whole parts out front together. So let's look at your number 20. I'm going to go 2 times 3 is 6, but I've got the 4th root of 8 times 2 is 16, x to the 8th, y to the 4th. Another nice problem, believe it or not, and you're thinking, oh no, it's not. So this becomes 6. Do you know the 4th root of 16? It's 2, because 2 times 2 times 2 times 2 is 16. So 2. X to the 8 divided by 4 is 2. Y to the 4 divided by 4 is 1. Final answer, 12 x squared y. And then we got it. Let me do 2 more with you, and then let's be done. Let's skip that one. And then let's look at your number 22. Notice, guys, that this is a binomial times a binomial. How do we take care of a binomial times a binomial? Good old FOIL. So here's what it's going to look like. I'm going to take 2 times 4, 8, and then I'm going to take 2 times the square root of 7, which is just 2 radical 7. Now let's go to the inside. So I got plus, let's go 3 radical 7 times 4. That's going to be 12 radical 7 plus 3 times the square root of 49. Hey, now go through and reduce anything that we can. Here's an 8. I'm going to combine these because they both have a square root of 7 in there. And I'm going to get 14 radical 7. And then this piece becomes 3 times square root of 49 is 7. So I really have 8 plus 14 radical 7 plus 21. Ending answer, combine those, 29 plus 14 radical 7. So good old FOIL. We did this exact problem in the previous chapter when we was working with the square roots. And then how about out of 22 or 23? Let's pick the one that looks toughest. 24 looks tougher because the numbers are bigger. So here goes. It's 2 binomials together again, so FOIL these bad boys. Hey, so check out what happens when I take this times this. 4 times 2 is 8. Square root of 2 times square root of 2 is square root of 40. Now let's go here to here. 4 radical 2 times 5 becomes 20 radical 2 minus, now let's go on this inner here. I got 6 square root of 100. Now let's do our last. So I'm going to have minus 15 radical 5. Now we're to an exact same problem like number 13. This becomes 8. Something that you know the square root of that goes into 40. Looks like a 4 and a 10. Plus 20 radical 2. Minus 6. The square root of 100 is 10. 15 radical 5 does not reduce. Now let's bring this home. The square root of 4 is 2. 8 times 2 is 16 radical 10. Plus 20 radical 2 doesn't do anything. 6 times 10 is 60. Minus 15 radical 5. Combine any like terms you have. And since there are no like terms, as ugly as it is, that's your answer. So, hey, looks like almost a 37-minute video. Hey, guys, and I know it's a tough day. Anytime I take your calculator away from you, I know we're going to struggle a little bit. So that should give you a strong half hour to work on your assignments. Pull up next to somebody, bounce numbers off of each other. Do not use the charts that we made last time. Do not use your calculator. Get good with these. Get good with these. Good luck, and we shall see you